Hi folks, thanks to be here for this talk about evolving your APIs, a step-by-step approach. I'm Nicolas Fränkel. I've been a developer for nearly 2 decades. I still think as myself as a developer, even though now I'm a developer advocate. Now about your APIs. I assume that you probably have already developed some HTTP APIs in the past. And as I mentioned, I've been a developer for some time, and I know that in projects, you have a lot of things to think about. For example, you need to think about functional requirements, but even about non-functional requirements. And so the fact that you need to version your APIs somehow, it's something that is for the long term. It doesn't fit in the current sprint, it doesn't fit in anything. So even if somebody thinks about, hey, perhaps we should do this, well, you don't have time to actually do it. And so when it's time to deploy a version 2 of your application, probably you might be a little desperate because you understand that you never planned for it and it's going to be a mess. So let's take like a basic situation. You have deployed your application and then it has a couple of endpoints and it needs to return data. And basically at this time you are exposing your application to the internet. And the beginning of the solution is to set up an API gateway. Then you can have as many services as required. And probably you are asking yourself the question, hey, but we have something here between the clients and our application, but we don't call it an API gateway. We call it a reverse proxy. And yes, I think that nearly 100% of all organizations in the world have a reverse proxy and not an API gateway. So let's stop a bit and think about what's the difference and what are the rules. So as you can see, I have gray hair, which means I'm quite old or in a positive way experienced. And I starting to use the internet 22 years ago, something around like that. And at the time, it was just the beginning. We were using emails and we were starting to create websites, really basic websites. My first websites had text, of course, but at the moment there were no CSS, there were no JavaScript. And actually, I remember having to, I wanted to style my site a bit. There were buttons, and I styled the buttons by adding tables because I wanted to add a bevel effect, and I created tables for a button. I mean, right nowadays it would be really bad practice, but at the time we didn't have no other tools. And at the time, I didn't care much, or I didn't understand. What I did is I just pushed the files to a folder, and magically I would go to a browser and they would be served somehow. And that was the web at that time. It was only about static content. And yeah, it was the time when actually there was no Google, but there were directories. So you would register to a directory. It was a tree-like directory, and you would say, hey, my site is about this stuff. And what about if you have multiple themes? Well, that was not the problem at the time. And so static content was really nice, but people starting to think, hey, but we want more dynamic content. So again, as I mentioned, I didn't interest myself in servers at the time, but I believe that the Apache web server, or what is now known as the Apache web server, was the one used. And when people wanted more dynamic content, well, what they did is basically they created scripts, like Common Gateway Interface, CGI scripts. They were written in Perls. And basically you had to write a Perl program that would write the entire HTML page. Now imagine that you would have no web designer, no nothing. You would have to think about the structure of the page beforehand. and you would need to write the Perl scripts with if, with loops, with whatever you needed. And somebody decided, hey, that's not very usable. Of course, it gets the job done, but that's not very usable. So I want to have a simple web page, and I want to insert in some places, I want to insert dynamic content. It can be like text, can be just a date, for example, or it can be an image, like an image generated magically by the server. And for that came PHP, and PHP was at the time personal M page. And the good thing about PHP is it became a module, an Apache Web Server module. So you had this Apache Web Server with like a module-based architecture, and you create a new module, and then you can register it, and then it's like you can create your PHP page, you put it on the server, when it is served, it gets executed, and the dynamic bits have been computed. That's amazing. Nowadays, of course, it goes as granted. Everybody takes it for granted, but at the time it was really, really cool. And of course, it took a couple of years, but some people, some organizations, some companies decided that, hey, it's an interesting channel. Perhaps we should like spend resources on this channel, because we see more and more people are using browser, are using the web. So perhaps we can design like a website that tells about our services. And perhaps they can ask for advices. They can contact us. The usual stuff that, again, is granted nowadays, but at the time it was like pioneering. But when you start having like a communication channel and you are a big enough company, you want that communication channel to be up all the time. And so the web server was not only about serving static content, was not only about serving dynamic content, but it had to do more. So you had like web server in front to do like load balancing and perhaps redundancy, and in the back there were like web servers that actually like served the content. And both of them were probably the same piece of software, Apache Web Server, but they had different like responsibilities. And after a time, it became really ubiquitous. Like it was not about pioneering. It was not about another communication channel. It was your main communication channel. And so at this time, you actually had a web server that became the single entry point into your like information system. And this single entry point had to like route the requests to the different nodes, because some nodes, I don't know, were for like public persons, for like B2B, and some others were for B2C and whatever. But you still had these like single entry points. And so the evolution of the web server like started from like really the most basic stuff, serve static content, and then you had to serve dynamic content, and then you had to load balance, and then you had to route. And so the web server that is the single point of entry can not generally just serve content. You can remove that port. It has become a reverse proxy. And with this single entry point, because now you only need to go through this point to enter the information system, then you can add more like cross-concern features such as authentication, authorization, caching, IP blocking, whatever you want. Great. But now we have to communicate with other information systems. And when you want to exchange information, again, I remember a time when you actually had to put a file in a predefined format on an FTP folder that was to be processed later on. This worked actually. This was the beginning of information exchange. It was asynchronous, so basically if the client didn't process the file, it would process it again until it was correct. So it was not that bad. But nowadays we want to have more like synchronous feature. When we want to exchange information, we cannot wait a day, we cannot wait an hour, we need to be it now. And it's fine if you work in the same tech stack. So basically all like legacy tech stacks, they have a way to communicate between themselves. Like in Java, before you had Corba, then you had like EGBs, whatever. That's nice. But not all organizations, they use Java. So you would have like Java companies, .NET companies, Ruby, Python, whatever. But they need to communicate somehow, even if they don't have the same tech stack. And the only, or let's say at this point, the most common brick among all of them was HTTP, and is still HTTP. And so the difference between like a reverse proxy and an API gateway is like features that are also cross-concern across like different channels, different requests, different endpoints, but that are really, really focused on an API. So this information exchange. So for example, with a reverse proxy, it will be hard to do billing. Like you need to authenticate and you need to understand how much will be charged to the person, and perhaps they belong to the same group or person, perhaps they belong to the same company, but still perhaps even if they belong to the same company, you want to charge them separately because they have different departments or whatever. It's possible. But you will need to write a module. So if you are using Apache or Nginx, you will have to write something that takes that into account. You need to write custom code. Likewise, we have been doing rate limiting since ages. Like you don't want your information system to be overloaded. So what you do is you say, hey, I don't want to have like more than like X requests per minute from like any IP address. Good. But perhaps you don't want to rate limit by IP address. Perhaps you want to rate by a client using your service. And again, we goes to the same way again. You need to like authenticate, to authorize. And then depending on the profile, we want to set different rate limits. Perhaps some people, they are paying customers of yours and they have a higher rate limit than people who just want to play with it, just as like developers, or it really, really depends. So my conclusion is you might have a reverse proxy and it's really, really good, but probably what you want to have is an API gateway. And again, API gateway should do everything a reverse proxy can do and add additional features. There are a couple of API gateways on the market, so here are a couple of them. And in this talk, I will just use Apache API 6 because A, it's written on my t-shirt, but everything that is in the demo, you can probably do with another of them. So Apache API 6 is an Apache top-level project, and that is important. That means that it has been donated to the Apache Foundation, it has gone through the incubation phase, and now the Apache Foundation has decided that it is grown up enough so that it can survive on its own. It's actually based on other open source components. So at the most like a foundational level, it uses Nginx. Then there is this open REST layer, which basically is a Lua engine. And then you have a plugin architecture, so you can have plugins. Most of the time you will write your plugins in Lua, but you can also write your plugins in Go or in Java or in other stuff. So now that is set, I hope that you agree that you need an API gateway if you want to manage your APIs. So first step is actually to put something in between. And this something is an API gateway. So throughout this talk, I will do a demo. This is the first demo step. So I prepared everything in advance. Here you can see that I've created a Docker Compose file to set up the entire architecture. So first, I will have an API 6 image here. And I don't want to delve into too much detail, but basically I have to mount some volumes for configuration, like to read the configuration for logs, to write the logs, I can consult here. And it depends on etcd. That's an important point. By default, API 6 depends on, stores its configuration in etcd. etcd is a key value store that is like natively distributed. It's the same store that Kubernetes uses, which is a good sign. And so here I have to set up an etcd. Just a word of warning, I'm like using another port because I'm using Docker Desktop, which has its own Kubernetes cluster, which relies also on etcd. And if I use the same, like the default ports, they will like get into conflict. So I need to set up another etcd with like a dedicated port so that I will have two etcd, one that I don't care about because it's the Kubernetes one, and this one that I care about. It's not necessary, but even if you are not using Docker Desktop and don't have Kubernetes, it won't change a thing. Now I want to show you afterwards the API 6 dashboard. It's not necessary, but I believe it's an interesting like way to look at your configuration. So not only it will be about command line interface, but we have a nice UI. Next is I want to monitor my my flow. So I have set up Prometheus and Grafana. And finally, I have like two APIs, the old one and the new one. And again, the goal of all this talk is to like seamlessly move clients from like using the old one to the new one. So let's start this Docker Compose file. So normally it should be pretty fast because all the images have been already downloaded, obviously. Depending whether you want to do this, it might take some more time, but it will be only about network time. So we can already check that everything works as expected. So I will curl my like old API directly, curl localhost. So the old API is set on 8081. And I want to tell them hello. Yes, it works. And if I want to query the new API, which normally shouldn't be set up yet, but I already like launched it. So those are the two versions. As you can see, one is much, much better than the other. And now I need to go through the single entry point. Single entry point is actually the port where I've deployed Apache API 6, and it should be 9080. And the first thing that I notice is it tells me that the route is not found. So basically, I'm sending a request to the API gateway, and it doesn't know to which upstream it should forward it to, which makes a lot of sense because I configured nothing. As I mentioned before, the configuration of API 6 is stored in etcd, but I didn't tell you how you can change the configuration. Well, API 6 itself has an API, so you can change the configuration. So if you want to do this at home, you can check the evolve folder, and I have all the scripts that are like step-by-step that I will do into this talk. The first one is called create direct routes. So let's have a look. All of them will be pretty similar, and I will focus on the Apache API 6 configuration bit. But here I want to explain you everything. So first, I don't assume that you have curl at home. I don't want you to assume that you have curl. So here I will be using Docker, and I will be using the curl image. Of course, if you have curl, you just need to use curl itself, and it will be good enough. I need to set up the network because I have already like launch my Docker Compose file, and I will launch a new Docker image. So they need to be on the same network to communicate. Otherwise it won't work. So I'm just telling, hey, use the network that is called Evolve API's default, which is the default name of the network. Then, and that's the important bits, I will use the routes API. So here I have an admin API. Inside the admin API, I have the routes. And I will actually put, so that means that the ID won't be auto-generated. It will be this one that is created. So I want to create the route with ID 1 with this data. So I can give it a name. Of course, it's optional. I need to give it methods. So which method will match and will forward it to the upstream. Likewise, URI. And here, the important bit is the upstream. So where do I want to forward it to if I match the method in the URI? And I want to send it to this upstream. And here I have a single node. obviously, in general, you would have multiple nodes. So you would have different load factors. You would have different algorithm. Perhaps you have round robin. Perhaps you have something else here. You can use anything. It's not that important. I have round robin because I have on a single node and it's good enough. And here I set the plugins. And as I mentioned, I want to observe what happens. So I will set the Prometheus plugin. Let's run the script. And now let's query the API gateway again. And now it tells me, yes, I found the route, and actually it has forwarded my request to the old API. But now we are back to square one, and we need to go a bit further because this is actually the initial configuration. This is the initial environment. So the next step is actually to start to version our routes. But we don't want to break our existing clients, so we will have the two routes in parallel. The first route is the legacy route, and we are happy for the moment to let our clients keep using it, but then perhaps you have documentation, and in the documentation you will mention, hey, here is the route you should use, and you'll create this route which starts with v1. So there are multiple ways to actually version your API. And there is a ton of literature around it, but just for the moment, just let me mention very succinctly that you have three basic ways. The first one is you set it in the path, just like I did. The second is you have a dedicated query parameter. It's also possible. And the third one is you have a dedicated header. So whatever you can do whatever you want. Apache API 6 can adapt to all threes, but here it's the most visual one. It's the simplest for the demo, so I will be using path-based versioning. And for this configuration, for this new route, I will start to be a bit smarter. So far what I did, I created the route and I created the upstream and the plugin configuration in the same requests. So I cannot reuse the upstream, for example. And in that case, I would like to reuse the upstream. So I will do as I would do in production. I will try to be a bit smarter, and I will create an upstream object with an ID. I will create a plugin config with an ID. And finally, I will create the routes that reference the IDs of both. So let's do that. The first is I create the upstream, and you can see here that I'm using another endpoint, and yeah, it's aptly named upstream. And here I will be creating the upstream directly, very easy. And here I will create the plugin configuration. Again, it's a different endpoint, but it's pretty self-describing. Now I create the version route. And I will do two things at once. The first one is I will change the plugin config that I've just created to add the proxy rewrite. Why I'm doing this proxy rewrite? This is very important. If I receive a request that starts with v1 and I just tell Apache API 6 to forward it, then the endpoint, the upstream, will get the path with the v1. And it doesn't understand v1, so far it understands only hello. So basically what I need to do is I need to change the forwarded request so that the v1 prefix is removed and it doesn't receive v1/hello, it just receives hello. So that's what I'm doing here. And the second is I will actually create the new route with a new ID, obviously. And then I will say, hey, you will use the upstream that I created just before, and you will use this plugin config. So let's create it. Now we can test it. And I will say v1, hello, and it works. Now I have two routes. How do we get the routes? Well, it can be pretty easy. Either you can curl it again and we can ask, hey, what are all the available routes? Now it's time to show you the dashboard. Here it is. So let's go to the dashboard and check the routes. And here I need to register like authenticate, and I've kept everything by default, admin, because it's just a demo. And here you can see the two routes that I have talked about. The first direct route, the inversion route, the legacy route, and the one that I've just created, which has all the possible mappings. And of course, through the UI, you can configure it, like if you want to do it through like the wizard, or you can also like check the JSON, because everything is JSON, and you can directly change the name. Let's say here legacy route, and I will submit it. And here now it says legacy route. So you have two ways to manage your configuration, either through the command line, which is very cool for DevOps minded people, or through a UI, which is for people who perhaps don't have so much experience with the command line or just need the visual way. What I do in general is I prefer to change through the command line and to visualize through a dashboard. Now, what we would like is to tell people, folks, this legacy route is not usable anymore. You actually need to use the version route. And for that, we have the HTTP 301 status code, which is great. So what we just need to do is, when we receive this request that is in version, we need to tell people, okay, use this one. So set the status code and set the new location in the header. You can do that actually for API 6. So here I'm using the first route, so I need to set everything in one go. And I will tell it that it needs to use the redirect plugin. The redirect plugins has those two parameters, URI. So here you tell the person where do you want to redirect to, and the return code, obviously 301. So when people request whatever, they will be met with this, and here, sorry, when people request the first route, very important, so basically the /hello or /hello/store or /hello/, they will get this 301 return code with the new location. Now we can test it. Oh, 301. So how do people know where they should go to? Well, the first way is they should be verbose. So here we can tell them that it's a 301 and the new location it's v1/hello. And notice that it works even if we added something like this. And it gives you the correct location right out of the bat. Of course, there is another alternative, is that the client like follows directly the redirect. So here it follows directly. So either you break the client because the client doesn't follow automatically, but they can check the logs and they can see, hey, in this header, like this is the new location and it's a 301, so it has been moved permanently, or they are automatically following and then it doesn't break them. You might say that breaking clients is a bit strong, and I would agree, but in this case, we don't have any choice because we don't know who is using our APIs. That's a real problem, that we should provide like incentives with people to register. First, of course, we need to provide some kind of registration channel, and then we need to ask people to register. But of course, because we are developers, I'm a developer, I don't like to register. So in order like to gently lead people to use our API, because still we want people to use our API, we should probably provide like two tiers. One is like limited and the other is whatever you want. The first one, you don't need to register. Perhaps you just want to kick the tires to see if it really fits your need. And then you want to be serious. You really want to commit something. You need an additional like rate, like more requests per second, then please register. So as I mentioned, Apache API 6 has a plugin architecture. You have a plugin catalog, and you can check the one that you need. In this case, however, there is no plugin for that. There are plugins for rate limiting, but in every case. So the idea is that you authenticate, and then you get this identity, and then this identity is limited by like X requests per second or X requests per minute. But there is nothing like I want, like to have these two steps. So what I did, and I'm not a Lua developer, is I copy-pasted one of the plugin and the plugin that does the rate limiting, and I added my own logic. And it's actually not that hard to do. So here, for on the user side, I name my plugin a not limit, so you can call it like this. I have like one counts over like 60 seconds. So if you call it like more than twice per 60 seconds, it will return you like an error code. I will use the like normal 4 to 9 error code, like rate limiting over the limits. I don't remember the name. And the most important part is the rejected message. And the rejected message is, hey, please register whatever. So you tell people how they can overcome this limit. And if I now run this script and I call, so I will directly use the v1 because it's easier this way. Yeah. So I can call, like I can have one call. The second request, it tells me, hey, you need to register. How does the plugin look like? Again, I'm not a Lua developer, so please be, if you're a Lua developer yourself, please be very, very nice. Again, what I did is I just copy-pasted something. So the important bits is here, you can declare your like local variables. Here, I have a local variable that I will use afterwards. It's schema, and basically it tells me what the configuration, what's the expected configuration for this plugin. There are some like optional fields, there are some required fields. Here is something that is very API sexy. Basically, you need, when you define this thing, when you define the plugin, you need to define the version, you need to define the priority. That is very, very important because all plugins have a priority. And when API 6 receives a request, it will apply the plugins in order. Of course, the plugin name, and the schema. And then the logic I just added is the following. So I overrode this maccess function. And then what I'm doing is I will check the key, and I will tell you afterwards where do I get the key. And by using the key, I will use another plugin. Does this key as like a user? And if yes, then everything is fine and I return. And if not, I follow the logic of the original plugin, which sets the rate limit. So now I need something. I mentioned the key auth plugin, and I need to create like an identity. And what I'm doing here, I've got another endpoint called consumer, and you can think about a consumer as a user, as an identity. So here, what I'm saying is when I'm using the key auth plugin and the key is my key, and then it will be user named John Doe. So let's do it again. Here, it tells me, hey, you have too many calls. So I will, as a header, pass the API key, and the value is my key. That's written here. Oh, what did I do? It's not X, it's H, header. API key, my key. I didn't run it. Now it works. So what happens is when I send this request, it goes through my plugin, this like custom plugin that I've created. In this custom plugin, what it does, it checks if there is like a header with the default is API key, so that I didn't override. And then it checks what's the value of my key. It checks in the consumer database if there is a user that has an API key, my key. Yeah, it has. It is called John Doe. And then say, hey, you're authenticated. And because I'm authenticated, then my custom plugin doesn't impose me any rate limits at this point. Of course, if I don't pass the header, I've already shown it, but let's be sure about it. Yes, and it tells me, no, you're limited, because I'm not authenticated, I'm not John Doe, I'm nobody. The next step is actually, we have this new version of the upstream, and we want to test it. But how do we test it? In general, we will do canary release, and that's perfectly fine. But I believe before canary release, we can do a bit better. So what we can do is just like duplicate the load and send it to the new upstream without and forgetting the results. The results are not important, but we will just check that the same production workload that works currently with the upstream v1 works also with the upstream v2. Does it produces like new bugs or whatever? Again, ignoring the response, but perhaps we forgot to do a check about a null value or a nil value depending on the tech stack. Just like duplicate the load and check what happens. For that, the plugin is named proxy mirror, and we will send it to these new like hosts. Now is the time to check the monitor, the Grafana dashboard. So here I have the default dashboard for MPI 6, and you can see everything has been monitored so far. What I did is I added like 2 widgets here on the dashboard. One to monitor the calls for the old API, one to monitor the call for the new API. So now that I have mirrored the traffic, how like the traffic will still go to the old API, but also traffic will be mirrored to the new API. And my idea is that I should have like the same curves, the same error and of course success curves on the old API and the new API. If I have a huge difference, then probably there is a bug somewhere. And the good thing again, it's I'm testing on the production. So here I will like send it a couple of times, John, I will just use it like here and here and here and perhaps Jane, Joe, it's not important. Now I should have like load enough. Here, of course, it's not production, and to have something on the dashboard. And indeed here I have like more requests. So I've sent more requests. And here we can see that it's actually 404. The reason for that is that at this moment there is a little bug. Is that I explained to you about the priorities, and the problem is that the plugin that actually removes the prefix as a lower priority than the mirror proxy. And so the mirror proxy is first applied, so it sends a load, and then afterwards it rewrites the request. And basically that means that the request that is sent to the mirror is actually /v1/hello/whatever. And of course, as I explained at the beginning of the talk, then this upstream doesn't know about v1/hello, it knows only about hello. So we are in the process of fixing this bug. But still, you should think about duplicating before doing canary release. And now it's time for canary release, and it's another plugin. This plugin is actually called Traffic Split, and there are many ways to split the traffic. So depending on your context, you can split the traffic depending on the header, and it might be quite smart at the beginning to say, hey, if my request has this header, then send it to the new upstream. And if it doesn't have, if it's the default one, then send it as usual. So you could have like your inner clients that are testing because they use this new header, and the external one that have no worries. Or you can do, hey, I want like 1% of all my requests to be like forwarded to the new upstream, and the rest be forwarded to the old upstream. There are many strategies. You can look at the documentation. Here, what I did for the purpose of this demo is actually to send half. So half of my request will be sent to the new upstream, and half of my requests will be forwarded to the old upstream. Let's run it. and let's test it. So here I should have about half of my return values that are sopped up. Over time it will be 50%. Quite good. Next step. At some point, I will probably want to decommission the V1. And at this time, normally, you should have people who are subscribed. So you could have like their emails or whatever, their contact details. So it shouldn't be that hard. Anyway, if you still don't have them, or for whatever reason, you also want to communicate with people who are not registered, then you can do it through HTTP. There is no official way to do it, but there is an ETF draft. And basically, it's a deprecation header. So this deprecation header can be either a date saying, hey, I will be deprecated at this date, or saying, yeah, yes, I'm deprecated. So it's up to you to decide how you want to communicate and what you want to communicate. Then you've got an additional header that says where is the new resource that people should use. So you can think about it like a soft 301. And finally, if you really want to manage the full life cycle, so not only about deprecation, but about when will it be completely decommissioned, there is a sunset header. So first, what I will do, I will create the complete route. Then I will change the V1 route with this response rewrite. So what I'm doing here is actually exactly what I described. I will add additional header. I will say, hey, it has been deprecated, and you can check about the new endpoint that you should use here in this link. Let's run it. And let's kill the V1. And of course, I forgot to be verbose. And here we can see that, yes, this endpoint is now deprecated, and that the link is the following, and it points to the V2, because here we just wrote V2, so it's quite easy. Now comes the final step, and the final step is to rest, because you have successfully applied all the steps that I've shown you, and in general, you should have covered most of the problems. And even better, if at this point you've implemented all the steps, when your business comes to you for the V3, it will be straightforward, because you probably will have registered the users, and probably you know how to set deprecation headers so that they are forewarned when they get to the service, and everything is fine. So now it's all unicorns and rainbows, and you need to handle the next problem. So thanks a lot for your attention. You can read my blog, you can follow me on Twitter. More importantly, if you want to do that at home, I encourage you to. Perhaps there are bugs, perhaps some stuff is not clear, and I am a firm believer that you can learn by doing. Go on GitHub, clone the repository, eventually store it, make pull requests, and have fun with the code. And if I got you interested in Apache API 6, then you are welcome to check our documentation. Thanks a lot for your attention, and I wish you a good day.